Hello, this is Angelia, and you are listening to or watching the podcast, Why You Do What You Do. The podcast about human development and psychology to kind of help you try and figure out why you do what you do a little bit more. Now, last time we left off talking about the information processing approach, and now we're going to kind of go further onto computer-based models. So here we go. Some information processing theories compare the brain to a computer. And I'm sure you've heard that. We start out and our memory banks are empty and we learn like computers and make, pathways and things like that, like computers. Fortunately, we're actually a little quicker than computers. Computers have more storage capacity, especially if it's a big nationwide thing, something like Google, But we do kind of grow in a similar manner. Sensory impressions go in, behavior comes out. And that's kind of the same with us. Anything we experience goes in, and then we behave on our environment based on that. But what happens in between? How does the brain take sensation and perception, say, of an unfamiliar face, and use it to recognize that face again? We have in our brain facial recognition, just like some computers have facial recognition software. And mine's actually pretty good. People say, who was that actor or whatever? And usually I can remember a face fairly well. Now, when I was younger, it was better because I've noticed as I got older, sometimes I have to see a person 2 or 3 times, before I remember who you are. Because I think with the stroke I had, I have problems getting names right. So I'll have to see you and hear your name several times now before I can get that right. Whereas when I was younger, it was a lot easier. Information processing researchers infer what goes on between a stimulus and a response. So basically, they're guessing, inference. When something happens is an experience, and then how you respond to that is, they're giving it their best guess. For example, they may ask a person to recall a list of words and then observe any difference in performance if the person repeats the list over and over before being asked to recall the words. I was in a spelling bee. I would have gotten first place, but I messed up on one word, and then they were going to disqualify the next guy because he came up and flicked me in the ear on his way by, and they were going to kick him out. And I was like, no, because he was already bullying me, so I know it would just be worse if I did that and I won. So I didn't do that. But I used to repeat a lot, and sometimes I still use that to remember things. I repeat, like if what time do I need to stop this? 23 after 23 to 23, to get it in there. Because, like I say, when I was younger, it was a lot easier. But I found since my gestational stroke, it's a little harder for me to remember. And as I'm getting older, like I said, when I started into my 50s and I was complaining about stuff, Dad's like, welcome to getting older. Everybody's like that. And I'm like, well, I'm not liking it. Through such studies, some information processing, researchers have developed computational models, flowcharts, analyzing the specific steps people go through in gathering, storing, retrieving, and using information. Because like some people have these little tricks to remember things. So this is something they've actually studied, and how people do it, and how your brain usually does it. How the average, remember everything's a law of averages, no such thing as normal. Some people go this way, some people go the average. Brains do things. Despite the use of the passive computer model, information processing, then their theorists like Piaget see people as active thinkers about their world, because we are. We're involved in every aspect of our world, and we think about every aspect of our world. So that shapes how we see our world and how we experience our world and what we do in our world. Unlike Piaget, they generally do not propose stages of development because they think everything is based on, learning what you've learned, and then you behave a certain way. So there's no certain stages of development in their theories. They view development as continuous and note age-related increases in the speed, complexity, and efficiency of mental processing, and in the amount and variety of material that can be stored in memory. So they're basically saying that, like a new computer, you would have to learn everything and how to do things, and then as you get older, that would get quicker. And then as you get more old, that will slow down, and that kind of is a fact of life. Neo-Piagetian theories. I wish I could just talk like I used to when I was young. During the 1980s, in response to criticisms of Piaget's theory, Neo-Piagetian developmental psychologists began to integrate some elements of his theory with the information processing approach. So they're kind of combining, the two. They liked some of his theory, but not all of his theory. Kind of like he felt, and Erickson felt about Freud's. They like some of his, not some of his. So, like I said, we build on the work that comes before us, and we are always learning new things. Instead of describing a single, general system of increasingly logical mental operations, Neo-Piagetians focused on specific concepts, strategies, and skills, such as number concepts and comparisons of more and less. Because these are something, that kids have to learn. The way you think about a thing is formed by your experience of a thing. So everyone's outlook can be different based on how they're experienced. And I gave an example in one of the other podcasts about if you were attacked by dogs, then this dog looks like a big scary dog. Whereas if you had a big, nice, fluffy dog, you may think this is the cutest little dog. So we all have different outlooks on things. Strategies. We will use what has worked before. Unfortunately, that's bad sometimes because sometimes you get rewarded for bad behavior. Like I said, these kids acting out, screaming, crying, and then the mother gives in. You've just reinforced their bad behavior. Skills, everything you learn is a skill. From raising up to operating on someone's brain, that's a skill. Number concepts, we're not kind of born with that. We have to learn to count. We just see this is here, this is a bigger pile than this pile. So that's something we need to learn. Comparisons of more and less. Like I said, we talked about where they had the ball of clay, and when it was round, and then when they rolled it out into a snake or worm or whatever, the kids always thought that was bigger because it took up more space. So even though it was exact same amount of clay, they thought the one rolled out was bigger. So, when you're young, there's errors in judgment that you make just because you're inexperienced, They believe that children develop cognitively by becoming more efficient at processing information. And intellectually, that's true. In all aspects of development, maybe not necessarily. But the better you become at something, the easier it is for you to understand. So, like if I was talking to a plumber about psychology, he's probably going to be lost. And if he's telling me about, certain joints or whatever, and, pipe fittings and things, I'm probably going to be lost. But the more I learn about that, the more I'm going to understand what he's talking about. And the more he learns about psychology, the more he's going to understand what I'm talking about. So, that is a true, theory there. Because of its emphasis on efficiency of processing, the Neo-Piagetian approach helps account for individual differences in cognitive ability and for uneven development in various domains. Because, like I said, the more you learn about a thing, the more you understand. So that also will make you want to learn more because you get it and you like it. That's why I said about, kids, send them in the direction of the things that they're good at. Because if you're good at a thing, it's going to come easier to you and you're going to want to learn more and you're going to be able to do that easier. And, as a being, we're not always about the challenge. You don't want to go into a field that you suck at as a challenge, unless you're just, that kind of gung-ho person that you feel like you need to do that. Most of us want to go into something that we're good at. That we excel at, because then, we feel like we can do better. As you learn more, it's easier to learn more. So, that's kind of the point there. And uneven development in various domains. Again, if you're not exposed to things, you don't know about things. And if you were not taught things, you don't know about things. Whereas if these children were all taught this, but you never were, you're going to be lacking in that area. So, again, it's important, parents, to take the time, to put the time into your kids. Currently, a number of French and Swiss researchers are exploring the multiple processes and individual pathways of development that Piaget, for the most part, treated merely as variations on a general pattern. Like I said, everyone kind of stands on the work that somebody else has done. That's how you learn more. As time goes on, you might find a piece, like they thought Freud's was all that. And then, Erickson is like, well, this is right, I think, but maybe not this so much. Let's test that. And they found it, yeah, and maybe not so much. So as we learn more and go on, we're refining things a little bit more. And, you can come up with good theories that you can prove. And so, that's how any field learns and grows. The cognitive neuroscience approach. Don't get scared of that word. For most of the history of psychology, theorists and researchers studied cognitive processes apart from the physical structures of the brain in which these processes occur, because they were concerned with the mental aspect of this. They weren't taking into consideration the physical aspect of your brain. But now we know those two go hand in hand. If there is a physical problem in the brain, that is going to affect that area of the brain. So, with mental disabilities and things like that, with injuries, that's going to affect the way you think and process. Now that sophisticated instruments make it possible to see the brain in action, adherents to the cognitive neuroscience approach argue that an accurate understanding of cognitive and emotional functioning must be linked to what happens in the brain. And that's a fact of life. Because they can actually study now. They can, hook you up to wires and look at the different changes, like the computer programs will have different colors, and you'll be able to see what parts of your brains are working and things like that. And you might not think mental and emotional processes both occur in the brain, but they do. Because your logical stuff is in the brain and your emotional stuff is too, the way you feel about things based on your experiences. Because that's where we develop our feelings about things. Something either affected us negatively or it affected us positively, and therefore we feel a certain way about it. Developmental cognitive neuroscience may explain how cognitive growth occurs in the brain, interacts with the environment. So again, you learn what you live. The more you interact with your environment, the more you're actually going to learn and experience. And, we hear college talk about a well-rounded person, and some of that I necessarily don't agree with as far as that goes. But in child development, it is a very necessary thing. And the more you let your child experience, the more they're going to learn, and the more they're going to want to learn. Developmental cognitive neuroscience may explain how cognitive growth occurs as the brain interacts with the environment. It may also help us understand why some people do not develop normally and why adults age. Because like I said, if you're not being taught things, if you're not experiencing things, you won't develop those abilities. So like in the case of Victor and Jeannie, they did not develop the speech and the personal, care and, things that an average kid takes for granted, they did not develop these abilities because they were not taught. And then, like I said, once you get past a certain age, your brain is not as plastic as it, was before. So it's not so easy for you to learn things when you get older. And they're also looking into why adults age, because that's a lot of the question of, why do older adults get dementia and Alzheimer's and things like that? How does the brain degrade? And if they can figure that out, there might end up being a treatment for that in the future. Brain research supports important aspects of information processing models, such as the existence of separate physical structures to handle conscious and unconscious processing. So they know there are certain parts of your brain, and they've done this, through sleep studies and things too, that are in charge of what's going on while you're awake. And there are other parts of your brain that are in charge of what's going on while you're asleep. The parts where, you're dreaming. And there's also parts that are kind of working on stuff in the background all the time. And like I know that's going on in my brain, because sometimes someone will ask me a question and I'll be like, oh, I know that, but I can't think of it right now. It's in there somewhere, but and then like hours later, minutes later, days later sometimes, poof, it'll pop up in my brain. So that's my unconscious brain. It was working in the background all the time on this without me being aware of it. And it found the information it needed and popped it out there to the conscious. I was like, oh, okay, I remember that, And sometimes it's odd because, like, oh, remember that question you asked me 2 days ago? That was this. And, that's funny. It is giving scientists insight into why certain common memory failures, such as absent-mindedness and difficulty accessing information in memory, occur. And I can tell you, in my case, I know that stroke had a lot to do with it, because I was not the same afterwards. And getting older has had a lot to do with it too, because I could tell you, 10 years ago, I was a lot more quick on the draw than I am now. Neurological research also may be able to shed light on such issues as whether intelligence is general or specialized, and what influences a young child's readiness for formal learning. And there are both. There are general intelligences that everybody kind of learns and goes through if you are raised at all. Like I said, there are cases where you're not, and that's a shame. And then there is specialized learning. Like if your mother was a music teacher, she might have taught you, how to play a lot of instruments and play the piano and things like that and sing. Whereas another child who didn't have a music teacher for a parent wouldn't have that. So it is both. There are general things that we learn as a society, how to feed ourselves, how to go to the bathroom, things like that. And then there's specific learning that we pick up based on our environment. And so when a child is ready for formal learning, it usually has to do with whether reading, language, and things like that were valued or stressed in the home. I remember, Sesame Street came out when I was just a few years old, and watching that all the time. And I had records where, we were singing the alphabet, and I had picture books. And I was, with my grandma, would sit there and, read the words and point the words out to me. So, when I went to kindergarten, my teacher was kind of amazed that I already knew some of the stuff these other kids didn't know. They didn't know their alphabet. They didn't know any words. So at the end of kindergarten, we had a little program and everything, and they brought my mom into the room, and she said, "You must be so proud of her," because my mom actually had said, "Get your stuff and hurry up and let's get out of here." And the teacher was like, "You must be so proud of her. She can read." And mom's like, "What?" And she said, "Go get that book off the shelf you were looking at the other day, Ange." And so I did, and I was reading it, and I was kind of nervous about it because I knew Mom wanted to leave. She wasn't caring what I was reading. She wanted to get out of there. So I was reading to her, and I saw the look of amazement on her face, and she said, "See, you must be so proud of her." And my mother was like, "Oh, well, I didn't even know that she could do that." And of course, once we got in the car, she's like, "I told you to leave," But, if you prepare a child, if a child is prepared ahead of time, and like when my little ones were in a high chair, they get done eating or whatever, and the bigger ones would be doing homework, and I'd give them a sheet of paper, and I would let them color, and then once they looked like they were actually trying to make something out of something, I'd say, "Okay, let's draw this line and draw this circle, and draw a line and circle, line and circle." They draw a line and circle, line and circle, and that's the beginning of learning how to write letters. Because every letter you got's got a line or a circle. So, you can prepare them, and you should. Social cognitive neuroscience is an emerging interdisciplinary field that bridges brain, mind, and behavior, bringing together data from cognitive neuroscience, social psychology, and the information processing approach. So, the social cognitive neuroscience has kind of combined all these guys, who are concerned with the brain, the structures of the brain, how they work. Your mind lives in your brain. Some people, kind of blur the lines and everything, but your mind is the sum of your thoughts and your experiences, and that lives in your brain. Your brain makes it possible to have a mind. And behavior, like I said, anything that happens in your environment affects you in some kind of way, and you are going to behave in some kind of way based on what you have learned. So they're bringing together all this data, and like I said, the medical community and the psychologists, have come together to see how these parts of the brain work, to help figure it out a little bit better. And they can help you learn how you process information, because not everybody is the same. There are people who have deficits. And it could be, like I said, a mental disability, a physical structure problem in the brain. And then they can learn how to better treat these things. Social cognitive neuroscientists use brain imaging and studies of people with brain injuries to figure out how neural pathways control such a processes as memory and attention that in turn influence attitudes and emotions. Because, like I said, everything does work together. And your neural pathways, like I said, every time you're experiencing something, your brain, your little neurons up there are forming connections, little lines that connect to each other. Just kind of like in the computer, they learn what operations go with what thing, so the more experiences you have, the more of these connections you make. So that helps your memory, that can help you attention. Now, there are people who say attention deficit is because of a physical problem in the brain, and it can be. It can be birth problems, not enough nutrition, birth injuries to the brain. It all plays a part. And also, there's some biology there. If if attention deficit or ADHD, runs in the family, there's a chance that, your child can have that. So, again, there's the nature and nurture thing happening there. And then, again, if there are mental health issues, such as depression, anxiety, bipolar, things of this nature, that is going to influence your attitudes about things. More positive people they do better. That's just a fact. More negative people never really do that great. They're kind of stagnant because everything has a negative spin on it. And your emotions, again. If you're very emotional, that can be hereditary, or it could be that you experienced trauma growing up. So, like I said, it all plays in. Ultimately, by shedding light on what neural and cognitive processes best explain particular social behaviors, social cognitive neuroscience may help to sift through competing theoretical explanations. Because, like I said, there are a lot of theories out there, so when they hook people up to these, machines and try to figure out what they're seeing and, what's happening while a person is thinking about this or talking about this, they can see, what's firing while they're thinking about this. So some of the social behaviors that might be good, they can chart, and some that might be not so good. How do you feel about someone that's not so good? So, they can chart these and figure out, what parts of the brain, are happening here. And, if there is a physical problem, they can, see that. Again, we are aware of each other socially. We should be. If you're not, then there's usually a problem there. And again, they can, look at the competing theories because, like I said, everybody can have a theory about anything that they'll make it right, but you might have some points. On a practical level, researchers can use tests of memory, attention, and language performance to figure out what brain systems are involved in such disorders as schizophrenia, anxiety, phobias, and obsessive-compulsive disorder. So, if your doctor suspected maybe this was a problem, you could send you to a psychologist who might send you to a neuroscientist and try to get this figured out. Because, these disorders, are pretty impactful in your life, and they're going to be impactful to the other people around you. So, these are things that they can chart, and then they can decide what is the best way to treat this. Is this a mental problem? Is this an emotional problem? Is this a physical problem? And then they can, treat based on that. And sometimes it's a combination, and they can also treat on that. Perspective for evolutionary sociobiological. The evolutionary sociobiological perspective is strongly influenced by Darwin's theory of evolution. And remember, we talked about that before. I don't think God is dumb, and it would be dumb to create creatures who could not evolve and adapt to their environment, right? Okay, so we're always learning and growing, meaning we're evolving as people, so don't be scared of the word evolution. According to Darwin, all animal species have developed through the related processes of survival of the fittest and natural selection. Because, the strongest, smartest animals live to breed. And nature will decide, what traits need to go to the fore. Like with giraffes. In an area they lived in, they might have needed longer necks to reach those leaves and be healthy. So ones with shorter necks might not have survived to breed. So, clanging going on over here. So, natural selection can happen. Individuals with traits better adapted to their environments survive. Those less adapted do not. So again, There's always changes in nature, and your life too. The better you can adapt, the better you can survive. If you're not very adaptable, that's a problem, and it's going to cause you problems. In nature, you would not survive. In human world that we've kind of made here, we don't have that so much. But you can have a pretty hard time navigating the world if you can't adapt. Through reproduction, more adaptive characteristics are passed on to future generations, while less adaptive characteristics die out. So again, it used to be, and this is terrible, but this is true, back in the 1800s when they started learning about medical things and, retardation is the word they use, things like that. A lot of people who were mentally deficient, according to them, were sterilized because they felt like they would pass those genes on to future generations, and then that would be undesirable. And now we know there are, hereditary chances. Like if you have one grandparent, then, you only have like a 1 in 4 chance of passing this, that, or the other thing on. So we've learned a little more since then, and, but yeah, it used to be if you were defective, I mean, we've all heard the story of, the Spartans, where if they had a defective child, they would, murder the child with a rock to the head or throw it off a cliff or whatever. So, thankfully, we have not kept those traditions, so that, our people who are special, can have good, full, meaningful lives like they deserve to have, Everybody deserves to have a nice life. As environments change, some characteristics become more or less adaptive than before. This accounts for the emergence and extinction of species such as dinosaurs and the dodo bird, and, evidently the Neanderthal. However, the Neanderthal is still hanging around because his DNA is found in most all, cultures' DNA. So, that was a joke a while back. They had a little thing about it saying, the Neanderthal has been gone for a long time, but never in history before has more of their DNA been roaming around the planet. So that's something, to think about. Well, that's where we're going to stop for today. So I hope this has helped you think a little bit more about why you do what you do. Until next time.